So this is mostly about exponents. I'm sure you've seen them before, but we're going to do them with variables now. Okay, so what we're going to be learning today are the rules of exponents. So these are basically how we manipulate and move around exponents. So for example, one exponent, or just the basic one, is, let's say, x to the 5. That's just x times x times x times x times x, right? 5 times, right? That's the most basic one. In the same way, we can do like 5 to the 4 or something. It doesn't have to be a variable here, right? 5 times 5 times 4 times, basically, right? So let's think then, knowing that 5 to the 4th is just 5 times 5, 4 times. What if we did 5 squared times, let's just say 5 to the 3rd? Well, if we simplify this down, 5 squared is 5 times 5 times 5 times 3. Here, if we simplify this down, that's 5 times 5 times 5, right? That's 5 times 5, and then this times moves down, times 5 times 5 times 5, right? So it's 5 times 5, 5 times. It's a mouthful, but right. And this basically, we can rewrite this as 5 to the 5th, right? It's the same property, but reversed. So this gives us our first property or rule. We're just going to call it the product rule of exponents. Right. So what this basically says is that when we have a certain exponent with the same base times another exponent with the same base, or two numbers with the same base multiplied together with different exponents, you add the exponents. So x to the a times x to the b is equal to x to the a plus b. We just demonstrated that here because 5 to the 2 times 5 to the 3 is equal to the 5 to the 2 plus 3, or 5 to the 5, right? That makes sense?
Yes.
All right, so just an example. Let's say I had 10 to the 5 times 10 to the 8. What do we get? Oh, sorry, I wrote that wrong. What do you get here?
It would be
Remember,
10.
yeah?
It would be 10 with the exponent being 13.
Exactly, right. So
Right.
in this case, our 5 is a and our 8 is b, and we just add them together, 13. So yeah, we just add these exponents. Right. So let's try it with the variables this time. Here, let me grab a different color and highlight this. Oh. Whoops. Bad. Okay. I'm just gonna highlight this. All right, so let's try with variables this time instead of numbers. Let's say I have x to the 6 times x to the 12th times x. Now remember, x by itself is just x to the 1, but we just write as x. So what do we get here?
X with the exponent being 18.
Close, right? So these two added to 18, right? But remember, the exponent of x by itself is x to the 1. So we have to also add this. So what do we get?
X with the exponent of 19.
Exactly. Also, you don't have to say x with the exponent of 19. You could just say x to the 19.
Okay.
Like x to the 19, basically. All Okay, so continuing on this, since x is a variable, x can equal anything, even more variables. So let's just say x is equal to y plus z. In that same way, y plus z to like the 3 times y plus z to the 5, these are still the same base, so we can still carry it out as normal. So what do we get here? Remember, same base, so this rule still applies.
So y plus z to 8.
Exactly, perfect. Yeah, you get it. We just add these two, and we get 8. Right. All right. Okay. This lesson's pretty easy, so I'll see if I can get on from this one quickly, and then okay. Here's a harder question. So with just knowing the product rule, we should be able to figure this out. But I'll just go through this one first in case it's a little bit difficult. So these are all multiplied. Here, we don't have to add the multiplication sign here. All right. Now, the way I would do this, there's a lot of different ways, but first thing I would do is separate each term by its base. So, or not base, like its type of number. So first thing I recognize is 2 and 3, very similar. Like they're both numbers without variables, and there's no other numbers. So I'm just gonna move these around. I remember I can do this because multiplication is commutative, right?
Right.
That means I can swap around anything. Like this can be 3y to the 7th x to the 4th times 2y x to the 8th. It doesn't matter. You can switch these around as much as you want. So I'm going to do a little bit of that switching around. I'm going to put 2 and 3 next to each other. Remember, separated by a multiplication sign. Right? Now I'm going to look for something else. So rewrite that back. Okay. Now the next number of similar terms I see are x to the 8th and x to the 4th. Now these, they're similar because they both have the same base, right? So I'm going to put these next to each other, times x to the 8th times x to the 4th, right? After that, I'm going to look at the next set of similar numbers, which would be y to the 1, but it's just y, and y to the 7th, right?
Right.
Now we can write these next to each other, y times y to the 7th. And now just through just basic math, we know 2 times 3 is 6, times x to the 8th times x to the 4th. What do we get from x to the 8th times x to the 4th?
It would be 6 times x and to 12.
Exactly. All right. Now what about for the y?
It would be y to 8.
Exactly. Yep. Remember, this is a 1. You caught that this time. Perfect. So yeah, that's how you do this. Actually, I'm gonna keep that up. Here, I'll give you an example. And you can try this one on your own. I'll make this a little difficult. So I'm gonna include 3 variables. Yeah. All right. Try this one out.
Okay.
Just let me know when you're done, and then we'll move on.
Yeah, okay.
All right, how's your progress?
Almost there.
Okay, perfect.
Hmm.
Do you get an answer?
Would it be 24x to 8, y to 9, and then z to 10?
Exactly. Perfect. You're getting the hang of it. All right. Perfect. Let's move on. So that's the first rule. The other rules are pretty similar, so we're not going to have as many examples, but all right, our next rule is going to be the product, or not product. This is going to be the quotient rule, also called the division rule, but just all right. So this is just basically, it's kind of the reverse of this. Here, take a guess. If we have x to the a over x to the b, what do you think it equals? Is the reverse at the top.
So x to a minus b?
Exactly. Yeah, you got it. Perfect. X to the a minus b. So here, I'll just go through this one then real quick because I think you're gonna get it anyways. 4y to the 7. So I'm gonna do the same thing as last time where I made it so that we're only dealing with the common thing. So 12 over 4 times y to the 15th or y to the 7th. Now remember, I can do this because it's division. So if I multiply this together, I would get this. These are the same things. 12 divided by 4, that's 3 times y to the 15th over y to the 7th, which is equal to y to the 15 minus 7, 3 times y to the 8th. We'll just write 3y to the 8th. Does that make sense?
Yes.
Perfect. All right, for the sake of time, we're just going to move on to the next rule. This one's pretty simple too. So this is going to be the power rule for exponents. Now this one's a little bit different, so I'll just show it to you instead. All right. So this is basically where we have an exponent with a power to another power. And this, we just multiply the exponents together. Turns into x to the ab. That makes sense?
Yes.
All right, so let's say I had y to the 6th to the 7th. What would that equal?
Like y to 6, 7? Oh, 6 times 7?
Yeah, 6 times 7. Right, so just get y to the 42. That makes sense?
Yes.
Perfect. Let's move on to the next chapter then. All right, this is a little bit of a harder chapter, so we're going to take our time here. So basically, we're just going to combine what we were just doing with a little bit more math. So have you seen a polynomial or heard of a polynomial before?
No.
All right. So yeah, I'll write the definition here if this helps you. So A polynomial is a special algebraic expression with terms, sorry, I read that wrong. With terms that consist of real number coefficients and variable factors with whole number exponents. All right, so this is a little bit of a confusing definition. So I'll just show you some examples. So polynomial. So keep in mind it says terms. So a monomial would just be one term, but a polynomial is multiple. It can also mean one term. So this would be a monomial, but it would also be a polynomial, right? This polynomial. This also polynomial. Basically, everything is a polynomial. But there are some things that aren't polynomials. It's usually when you have the variable in the denominator. So no variable in the denominator. That makes it not a polynomial. So for example, let's align this. Like this would not be a polynomial. Not a polynomial. Now, keep in mind, when we have a negative exponent, actually, we're going to get into that later. Let's not use that for now. This is not a polynomial because the square root of x is also the same thing as x to the 1/2. And remember, we need a whole number exponent. So this would not be a polynomial. That makes sense? All right. I know it's a little bit confusing, but here, give me an example of a polynomial. Just any polynomial. Any polynomial. You have an infinite number of possibilities.
3x plus 5y.
Yep.
2, 3. Yeah.
Yep.
Sure.
It's polynomial. Perfect. All right. Okay, let's move on. So now we're going to talk about the degree of a polynomial. So it's just more polynomial classification. This isn't too hard. Polynomial. This is just basically how many exponents, or like the exponent of a variable, right? So, exponent of a variable. So for example, let's say we had x squared here on term degree. See those tables. So let's say we had x squared, the degree would be 2 because that's our exponent, right? Let's say we had our degree would be 4 because we have a 3 here and we have a 1 here. So we add up all the things. Sorry. Let's say we had same thing. These are all exponents. We add them all up. What would here, I'll give you an example. What would the degree of x squared y to the 3rd be?
5.
Exactly. Perfect. You got it. All right. Now some more of the things. Let's say we just had 2x. So remember, x by itself is here. Let's write this over here. X is also equal to x to the 1, right? That's just some basic property. So that means the degree of this would just be a 1, right? Now, what if we had something like just 2? We don't have an x term, but what if we actually did have an x term? 2 is also equal to 2 times x to the 0. What's x to the 0? Did you learn this before?
No.
All right, so any number to the 0 power is 1. Now, it's not technically proven that 0 to the 0 is 1, but if you look at the limits, it's also equal to 1. Right, so anything to the 0 is 1. So that means 2 is equal to 2. Let's substitute in the 1 we know for x to the 0. 1, 2 is equal to 2. So when we have this here, we can also think of it having this. Since we have a 0 as the exponent, our degree is 0. But we don't have to include this part. We just know when there's no variable, the degree is 0. That makes sense?
Yes.
All right, perfect. Also, same thing when they're talking about, so this is the degree of a monomial, right? A term. But when they talk about the degree of a polynomial, you add up the degree of each term. So let's say we add polynomial 3x to the 5th plus 2x to the 4th plus 3x to the 3rd. Our degree, we would just add up the exponent of each of these. So that'd be 5 plus 4 plus 3, which would just be 12, right? So what would the degree of this be? Oh, wait. Hold on. Wait, my bad. Sorry, ignore that. So the degree of a polynomial is actually the largest term. Yeah, sorry, I was a little confused. So this would be 5. So what would the degree of 6x squared y plus 3xy squared be? So we find the degree of both these terms, and then whichever one is larger, or even if they're the same, that's the degree of the polynomial. What would this one be?
It would be 4.
Not really. So what's the degree of 6x squared y?
3.
What's the degree of 3xy squared?
2.
So we
5.
also have an x to the 1 here. So this is a 3, right? Same thing with the y here. You got that one. But remember, the x is also has a 1.
Yep.
So that means our highest term or our highest degree is 3, right? Because these are both 3. There's nothing higher. So it means the degree is 3. So there's like ways that people classify these in terms of like how they'll mention them. So I'll just show you real quickly. You're not going to come across this very often, but they're gonna, when they classify, you're gonna need to know the degree of the polynomial, and then how many terms there are. Now, the number of terms actually plays into the name a little more. So if we had like 5x to the 7th, our degree is 7. So, but our number of terms, we only have 1 term, right? Sorry, this looks a little bit like 6. So we only have 1 term. So we're going to say monomial. I think I mentioned this in the beginning, but a monomial, M-O-N, we know that means one, right? So monomial. So that's going to be the one terms, right?
Mm-hmm.
So altogether, you can write something like monomial degree 7, but it doesn't really. Either way is fine. I don't care which one you use. So with two terms, here I'll just show you number of terms. 1, 2, 3, 4 plus. So one is going to be monomial. Oh, what happened there? Monomial. 2 is going to be binomial. Take a guess. What would 3 be? So we have mon, bi. Okay, this doesn't matter too much, but this would be our trinomial, right? And then anything 4 or more, we'll just call a polynomial. The thing is, polynomial can refer to like all of these as well. Like a monomial is a polynomial, a binomial is a polynomial, a trinomial is a polynomial. But only in some cases the other way around. Right. Okay, let's move on. Okay. So when we see, okay, so is everything making sense so far? I don't want to rush you if it's not making sense. All good, or you explain anything?
No.
All right, perfect. Okay. So we'll move on to how you write these. So this is probably the most simplest part. So you're going to learn something called standard form. Standard form, right?
Yeah.
Now, standard form is just how we write these. And the way we write this is like the way they show, in my opinion, is a little bit confusing. So I'll show you my way and I'll show you their way. You basically write it from highest degree monomial, highest degree term, and then all the way down to lowest degree term. So you just kind of like order it. The way they show, it still makes sense. It's just a little bit confusing. So a to the n, x to the n, and then plus a to the n minus 1, x to the n minus 1. So the what's it called? The degree is going down over time. And then so on, goes down another one, and it just keeps going on to infinity. But how I think of it, you just order it from largest, highest degree to lowest degree. So for example, if we had something like 3x minus 4x squared plus 5x cubed plus 7 minus 2x to the fourth. I first find the highest degree, which is 2x to the fourth. So I can write a 1 on this. You don't need to because it just kind of comes instinctively. But for the sake of the example, I'll just show you. Second highest term is 3. Third highest term is 2. Fourth highest term, 4. And then last term, 5. And this is the order we write it in. So negative 2x to the fourth. Remember to carry the negative. Plus 3x minus 4x squared plus 5x to the third plus 7. Wait, hold on. Wait, I didn't do that in the right order. Oh, I accidentally went opposite. So we go 1, then 2, then 3, then 4, then 5. So it goes 5x to the third. This was supposed to be a 4. 5x to the third minus 4x squared plus 3x plus 7, right? Yeah, these numbers confuse you. You can just order from highest to lowest. Here, let me give you an example. Try it out. It's not too hard, so it shouldn't take you too long.
Okay.
All right. What's our highest degree?
8.
Hmm?
8.
Okay, so we don't add up the degree. We look at the highest degree term.
4.
Yeah, so first we write negative 3x to the fourth. What's next? Which term?
3.
Which term is that?
3x to 3.
Yep. Just remember, we carry the negative 2. So
Okay.
what's next?
And then 2x to 2.
Yeah, and then?
And then 5x to 1.
And
And
then?
then 7.
Perfect. All right, sorry, give me 1 second. All right, sorry, I'm back. All right, so, okay. Yeah, it seems like you understand this. Let's move on a little bit. Okay, now there's more classification you can do. I don't really see a point, but it does come in handy. So we're gonna go over it. This is basically just further going over it. So let's say we had the degree, give an example too, and then the name. So when we have the degree of 0, that's basically just any constant. So let's just say 5. The name we call it is just a constant. Right. When we have a degree of 1, that could be like 3x plus 3, right? This is a degree of 1. We call this linear, right? We call it linear because 3x plus 3 is actually a graph, right? Something like this. And since it can create that line, it's a linear function. So we just call it linear. When we have 2 degree, second degree, we could have something like x squared plus 3 or something. We call that a quadratic. Now you haven't okay, let's see. Have you seen these before?
No.
All right, so draw this better. This is a quadratic equation. It's basically, let's say we had y is equal to x squared plus 3. Now the thing with squared is that as we go up, as x gets higher and higher, y will get higher and higher faster because we're squaring it. Right, so that's why it kind of looks like it's speeding up and makes a curve. So that's our quadratic. Right, and then let's say we have a third degree. This is going to be cubic. X to the third minus 2 or something. This is an interesting graph. It looks something like, oops, bad. Something like this. That's a cubic function. Past that, we have 4. It's called a, okay, so the book doesn't actually, I'll just tell you anyways. The fourth is a quartic, but they just call it 4th degree polynomial. I guess they technically don't need to classify past this because this is still not super high level math. This is, let's just say x to the 4th. This is basically, it looks like basically the exact same as this, except it's like steeper. So like this. Steeper than x squared plus 3, but x to the 4th. It's not too bad. All right, and so we're gonna, you've done these. So next example, you've done these before, but I'm just gonna let you do an example. So we're just gonna solve polynomials or evaluate them, not solve. So, hold on. Sorry. Evaluate 3x minus 1. X is equal to -3/2. So when we see this, we just plug it in. Now you've already been doing this in past lessons, so this shouldn't be hard to you. We just fill it in, -1, then we simplify, -9/2, -1. You can keep simplifying down, but I would, yeah, I'd say keep simplifying down. -2. That makes sense?
Yes.
All right, here, I'll give you one to try then. Evaluate, I'm gonna add in some squareds. X is equal to -1. All right, try this one out. Let me know when you're done.
Okay.
Have you figured this one out yet?
Still working.
All right, I'll give you 2 more minutes. Then I'll just go over it. All right, get the answer?
Um, -6.
Nope. Here, I'll just go through it. So first thing, let's just substitute in our x for where we have an x. So here we have an x, it's -1 squared plus 2, -1 minus 1. I think I know where you messed up. So what is -1 squared?
-1 squared. -1.
So remember, -1 squared is -1 times -1, right? And that means that it's a negative times a negative, which would mean get a +1. Does that make sense?
Okay.
Have you learned that before?
No, we haven't really learned this before.
Like negative times negative
Uh,
to a positive?
we learned that a bit, but we never really like focused on it.
Okay, here, I'll just do it a little bit quickly then. So a negative times a negative will give you a positive. A positive times, all right, a positive times a negative will give you a negative. A positive divided by a negative will give you a negative. Negative divided by negative will give you a positive. So basically, negatives, they will cancel each other out here. This is the one place where two negatives make a positive, right? And then when they're not both positive or both negative, it'll carry over. That makes sense?
Yes.
All right, so what would -2 times -3 be? Negative times negative. What do we get?
5? Well, 6, not 5.
I think you focus too much on the negative. All right, but yeah, that's right. All right, so that means our -1 squared becomes a 1. Our 2 times -1 becomes a -2. -1. Yeah, I think this is where you messed up and got -6. But yeah, we just get 3 minus 2 minus 1, which is equal 0. All right. All right. They also do a quick demonstration of a sphere, just the sphere formula because it's cubic. So I'm going to show you an example because I think this might come up in the homework. Volume of a sphere. Okay, I'll just draw a quick sphere here. It's going to be terrible, but this is our sphere, our center, and our radius. Right. Here, let me finish this. And then, all right, here's our sphere. So volume of sphere, volume is equal to 4/3 pi times r cubed. Now our r is our radius. So basically when they tell us the radius, we can find the volume of a sphere. So let's say radius was 5. Well, then we could just plug this in. 4/3 times pi times 5 cubed, which is 125. Simplify this down. This becomes, hold on, 125. This doesn't come out cleanly, but yeah, you get it. So it's something like it's just 500 over 3 pi or 500 pi over 3. But yeah, you get it. With the radius, you cube it, which remember, cube, r cubed is just r times r times r. So with r equals 5, r cubed would equal 5 times 5 times 5, which is 5 cubed. It's not too hard. Okay, let me look at the next chapter. Okay, I think I can get through this pretty simply. Okay, we're going to adding and subtracting polynomials. So this isn't too hard. Basically, the one thing you remember is you can only combine two polynomials when the variables are the same. Same variable and exponent. Add and subtract. You can do, right? So let's say we had 5x squared plus 8x squared. Quick check, x squared is equal to x squared. This goes through 13, or sorry, 13x squared, right? Let's go a little bit more advanced. When we have something like, we can actually, let's just ignore the 3x for now. The plus 4x minus 5. We can distribute this out, the plus, so it becomes plus 4x minus 5, right? Because plus times negative gives you negative. And then we can include the 3x again, 7x minus 5. This is just the distributive property. I'm pretty sure you already knew this. When you have something like 3x minus 4x minus 5, you actually have to distribute the negative to each of these. So it becomes 3x, 4x times negative. And so you can also think this is -1, but either one, we'll just keep it as -1. 4x times -1 minus 4x, -5 times -1 plus 5, -x plus 5, or 5 minus x. That's not too bad. I'm gonna go through this pretty quickly, so. Okay. Yeah, let's do one big example, just in case.
Okay.
Sorry if I'm rushing. If you have a question, just ask it.
Okay.
All right. Now, since this is a plus sign, we don't need to do any distribution. There's no sign here. We assume it's a +1. So 3x squared plus 3x plus 5, we can remove the parentheses. Same thing here. Distribute the plus sign so it doesn't change anything. And now we can group it together based on degrees. So it's like what we did our first exercise where we had the multiply. We kept the terms next to the similar terms. So in this case, it would be 3x squared and 2x squared, which we put here. And then we did 3x and minus x, which becomes plus 3x minus x. And then we'll have plus 5 minus 2, plus 5 minus 2. All together, we end up with 5x squared plus 2x, and then plus 3, right? And since these have different degrees or different exponents, you can't combine them. We just keep it as this. Does that make sense?
Yes.
Perfect. All right. Let's see. I guess I'll show you more about subtracting. So you saw what I did before with the distribution. There's like another way you can see of it. Let's say we had something like 3x squared plus 3x plus 5, right? In parentheses, and we were subtracting 2x squared minus x minus 2. Now, the thing is, we're subtracting this entire whole from this, right? So if we were to not have these parentheses, or if we did it wrongly, it would turn to 3x squared plus 3x plus 5. And then if we didn't have these parentheses, it would just be minus 2x squared minus x minus 2. Now this isn't correct because we're not subtracting this entire whole like we were supposed to. We're only subtracting the 2x squared. Now we still do have minus signs here, but it's still the same thing. It doesn't work like that. So what we have to do is we distribute this negative sign to each of the terms. Here, I'm gonna use a different color. Distribute the negative sign to each of the different values here. So for example, we can keep this front part the same because there's no sign here, right? There's no sign. So this becomes 3x squared. You can also remove the parentheses because we distribute the plus sign. And now let's start distributing this minus signs. So we have our minus 2x squared. And then since this is a minus and this is a minus, it's a negative 1 times a negative x becomes positive. So plus, plus x, right? And then our final term, same situation, negative 1 times negative 2 becomes a plus 2. And now we can just distribute these like normally. Here, I'll move the sign. So we have 3x squared minus 2x squared. So these were these and this here. And then we'll have plus 3x plus x, which would be our, should be this and this right here. And then we'll have our plus 5 plus 2, which we got from here and here. That makes sense?
Yes.
And all together, we can simplify this down. 3x squared minus 2x squared, same variable. So we just use the coefficients and subtract. 3 minus 2 comes 1, so 1x squared or just x squared. 3x plus x, same variable. So we can just add the coefficients. This one has an imaginary 1 coefficient because anything times 1 is equal to itself, right? So we just assume the 1 is there. So this becomes 4x, right? We just add the coefficients and then 5 plus 2 plus 7. That makes sense?
Yes.
All right. Here we have 5 minutes, so I'm gonna give you one to try on your own. Let's do minus. All right, try this one out. We only have like a few minutes left, so I'll give you 2 minutes and then I'll explain it.
No.
All right, did you get the answer?
Not yet.
All right, we don't have a lot of time, so I'll just explain this. So remember, this first parentheses you can remove because there's no sign. And we assume there's a plus sign, so we just distribute the plus, which doesn't change anything. Now we distribute our negative sign to each of these. So it becomes negative 6x squared, negative and a negative, positive plus 3x, negative and negative 1, positive plus 1. Now we group them together. Minus 2 plus 1. Right. Now 2 minus 6, we get a negative. 4x squared, we add these together because they're the same exponent. Then 5x and 3x, same exponent, which is 1, but just assume it's not there, or assume it is there, but we don't write it down. Add the coefficients, 5 plus 3, 8x, minus 2 plus 1, same degree of 0, right? Because it's x to the 0, so you can assume that. So then we just add that together, we get minus 1. So that's the answer. That makes sense?
Yes.